we'll wrap up. So in terms of our acknowledgement, which I think is really key to all sorts of sustainability aspects, we recognize the original inhabitants of Calgary, which is where I'm located, including the people of the Blackfoot Confederacy, the Siksika, Kainai, Piikani, the Tsuut'ina, Ixay, Nakota nations, and the Métis Nation, Region 3. So in terms of some updates, maybe I'll turn that over to you, Amy. You want to tell us a little quickly about, I know you've gone through some different iterations, but yeah, we're all excited to hear how that's going.
Yeah, iterations is a good description, I think. So I think I've had the chance to meet everyone, but my name's Amy and I have a new title. I'm the climate specialist at Bow Valley College in Calgary. And for those that have heard this 100 times, I apologize, but we have a consortium of post-secondaries and school boards that are exploring the idea of a power purchase agreement. So it's the Calgary Board of Education, Edmonton Public School Board, Bow Valley College, Northwest College, MacEwan University, and Keano and Portage colleges as well. And we had posted a RFP for a consultant back in April, I believe, and the RFP closed in May. And Stephen and Jason are also on the call. So if there's pieces that I missed, you can help fill in the gaps. Essentially, we decided not to move forward with hiring a consultant to kind of help us figure out if the power purchase agreement is the right way to go. And unfortunately, I can't share the details of why we made that decision, but I can share that we're still moving forward as a consortium. We've actually just drafted an amendment to kind of commit to keep working together for at least the next year to keep exploring what it might look like to do collective renewable electricity purchasing. So the stage we're at now is we're all kind of going back to our individual energy consultants and seeing if they can provide us with some guidance. But we're just finding there's a lot of different opinions out there about whether a PPA is the right direction to go or whether it's not moving forward. So if anyone has any reflections on their thoughts on a power purchase agreement, especially in the public sector, we'd love to hear it. Oh, hi, Karen. Nice to see you as well. But yeah, right now we're just kind of taking a step back and doing more of a investigation into power purchase agreements overall. So I don't know if that's at all helpful to provide that update, but just a commitment that we're still exploring this. And as we go along, I'm happy to share more learnings that we can. But yeah, if anyone has any thoughts or questions, feel free to reach out to me afterward. We're definitely still in this learning journey, recognizing this would be a big commitment, right? Having our purchasing and our risks kind of intertwined as large institutions. And so we're really committed to making sure we're doing our due diligence that this is the right path forward.
Excellent. Thanks, yeah, no, appreciate that. I appreciate that update. And it is helpful just to know. I mean, it is a complex thing to approach. I do know some folks, they're not necessarily post-secondaries or educational institutions, but have contacts who have gone through the process. And again, probably not as complex because it's not been collectives, but that may be able to provide some feedback. Have you been in touch with the Business Renewables Center at all through Pembina?
Not recently, but yeah, they have the resources on their website. And I think what I'm realizing is, excuse me, there are examples of public PPAs, but there's much more examples of PPAs through the private sector. And so I think Alberta's kind of in this learning process of, okay, what does a PPA look like for the public sector, especially when you have 7 large organizations that are partnering. So yeah, as I say, I think the sector itself is also learning at the same time. So it's good to share those back and forth.
Absolutely.
Thank you for your comment.
Yeah, they're not. Oh yeah, please go ahead, Aaron.
Yeah, well, can you remind me what your total purchased ask?
A very significant purchase, maybe one of the largest in Alberta's history. So the potential is quite enormous to reduce costs and really take a whole bunch of emissions out of the air.
Cool. Thanks.
Any other questions on that? Or, you know, and I think what part of this opportunity is, it's not closed. if there were institutions that, you know, watch this going on and are interested in pursuing something similar or joining that group or creating a different group, I think there's different opportunities that way. And along those lines, we're having some really interesting conversations with Bernice and some of the folks in Sask Polytechnic in Saskatchewan. Had a meeting recently with some of the folks there in operations as well as on the academic side, and Canria, and we're setting up meetings with Sask Power, because obviously their regulatory environment is quite different. But looking forward to continuing those conversations and seeing what's possible in different regulatory requirements, environments. And what we found is Canria is very positive. They actually think that it could accelerate their process by being able to work with Sask Power and work through the more provincial institutions there. So we'll see how well that goes. And there may be opportunities elsewhere. Obviously, we know in Saskatchewan the solar resource is the best in Canada. In some parts of the province, it's better than what we have in Alberta. So certainly exciting opportunities in that regard for our public institutions.
Yeah,
go ahead, please.
I just want to jump in and say that I can reach out to somebody at the province of Alberta.
I think that gives all our introductions, and really appreciate you guys taking the time to go around. I think there's so much value in being able to connect in that way. So thanks very much for that. Spencer, I think we can turn it over to you now if you'd like to introduce yourself, maybe go through your slides, and look forward to that.
Okay. Yep. Hello, everyone. My name is Spencer Wood. I'm the Director of Facilities at Humber College in Toronto. I have a presentation that I'm going to try and share. Tell me if that worked.
Yes, it worked.
Okay, good. All right. So I'm going to talk about sort of three things today. The first is Humber's Energy Master Plan, which we've had in place for a while, and we've done a lot of projects under it, and we've got some results. So we'll talk about that first. And then projects that came out of that, sort of two signature projects that relate exactly to what everybody's been talking about today. One is a passive house retrofit project where we took a building to extraordinary insulation standards and the results that came from that. And the second, let me turn the phone off. And the second is what we're calling Project Switch, which is our decarbonization project for our central plant. So in case anybody doesn't know, Humber is in Toronto. We have two campuses. Where our main campus that we're going to mostly talk about today is near the airport. You fly over it if you're flying in Pearson. We have about 35,000 full-time students, so we're pretty big. We have a second campus down on the Lake Ontario, about 50 buildings between them, 3 million square feet of space. So there's a lot going on. It's a big place. And in around 2015, we were setting sustainability targets, and we realized that to hit those targets, we were going to have to do something a lot more strategic with energy. In the past, we were doing incremental little projects as things came up, but we weren't looking at it strategically. So we went on a year-long project to develop this integrated energy master plan, which we did. And the process here is almost the most important thing than the to-do list, because we took the entire organization through the process together. So this is who was involved. So we had two VPs. We had an academic VP and the admin VP. Then we had people from facilities doing the actual work, but we also had purchasing and the students and sustainability and finance and people from the academic side. And we had milestones through the process. So when we're doing the benchmarking, we say, okay, we need to set benchmarking, and we would go away, we do all the research with the consultant, come up with what we think it is, come back to the committee and show them what we found, and together agree on the goals, which I'll show you in a minute. And then we would go on to the next piece where, okay, what are we going to do? And we go back and we come back and we all agree on what the goals are. So it was a very, very powerful process. So by the time we got to the end of the process, we had an ask for the board where we need to spend this much money for this much payback and all those sorts of things, and the environmental benefits. And since then, we've been operating under that agreement. So I've only had to sell the energy project once. Maybe I got approval twice because of the size of the district energy project, but every other project has fit under the energy master plan. And here's the goals that we're operating under. So we benchmarked, we looked at benchmarking against other institutions in Ontario. We found we weren't doing too bad compared to them. So we started looking other places. And so the best in the world we found would meet these numbers. They were in Europe. So 50% reduction per square foot in energy, water 50% per student, carbon. So carbon in 2015, when we were talking about this, wasn't the driver. That sort of changed over time. Fortunately, the plan was flexible. We have a 30% reduction goal in our master plan. We since have a 2050 goal for net zero, but that's not what we had in the time. We have financial goal of a 7% IRR, and we have an academic goal, trying to bring in the academic side. That's obviously important for teaching people how to do it, but it's also very important for convincing the organization that we should do this. It was very, very helpful to get the buy-in from the academic side of the house. So the projects we've done are exactly what you would expect. I'm not going to get too much into this today because we've got lots more to talk about, but happy to talk about it if anybody's got any questions. The one thing that might set our plan apart from most others is a significant emphasis on building envelope work, which doesn't normally show up because the paybacks are really long. We managed to blend the payback for the envelope work with the shorter payback from the other stuff to get an overall payback that everybody was happy with. But we have reskinned or done work on 1, 2, 3, 4. There's a couple more since I put this slide together, actually. So it's probably about 8 buildings we've done so far. That's changing windows, that's overcladding. Some cases we removed the whole wall of the building and rebuilt it. That's parapets, that's roofs, all kinds of stuff. I'm going to talk a little more about it later, but we have been putting a significant emphasis on building envelope. So we have a bit of expertise in that at this point. We've done lighting, as you would expect. What might be a little bit different here is we did full redesign. So we went from a classroom, if there was 16 fixtures before, we redesigned it. Now there's 12 LED with a lighting control system. We're using Incilium. So we have a pretty big Incilium system at this point. And it has worked really well. The lighting costs have dropped through the floor. So we're really happy with that as a design solution. Metering, a couple of people have mentioned metering today. First thing we did was we started the metering process. We spent over $1 million on metering. So we're trying to meter at the building level. And even within that, we often put in one of those multi-port meters at the building level. So we're actually capturing the main loads in the building. And it all goes back to a central server. And then we're just starting now to pull that data into SkySpark to do some fancy analysis with. But yeah, we went big on metering. Electricity, gas, steam, water is what we're measuring. We also realized that we need to get into the new construction standards as well. So we took everything we learned from the retrofit and set some pretty aggressive new standards. We're building to LEED Platinum. We're setting very aggressive energy numbers. We're currently building a building to 75 equivalent kilowatt hours per meter squared per year. And it's a big building. It's almost 400,000 square feet. They seem to be meeting that fairly easily in Toronto, so we might push that number down even further. We have TEDI numbers for the thermal. All of that's gone pretty well from that perspective. Solar, we have currently have 1.3 megawatts installed. A lot of that's on this, the picture on the left is our parking garage, which we covered the roof and the wall, the side with solar panels. That worked out pretty well, but we have it on a lot of the other roofs as well. That's been very successful. It's been, once you've got it up there, it doesn't really, you don't have to do too much to it. So in terms of results, it's been a little hard to track our results since the pandemic, frankly. So I apologize in advance that this is 3 years out of date. But so this goes right up until March 2020. And at that point, our energy savings of that 50% target were at 17, almost 18%. Our water was, we were halfway there at 25%. We did a project on that as well. Greenhouse gas emissions is been more challenging because it's an absolute goal, and we were adding buildings at the same time. So that means to get to -5%, we had to absorb, no, not really absorb, we had to eliminate the carbon from those buildings first to get down below the baseline. So that's why that one's been the most challenging, because of the growth in buildings. At that time, when those buildings were coming online in 2017, 2018, we didn't have the new building standards in place yet. So we weren't building net zero carbon buildings at that point. But we're very happy with the financial savings that have come out of this. So essentially, these numbers are not messed with at all. These are straight dollars. So the top line shows the increase in our square footage over the last 7 years or so. And at the same time, the utility costs have been dropping significantly. It's mostly electricity, some gas. The financial people at the college are thrilled. It's given us a lot of credibility when we get to the next project to show that the savings is working, because it is. It's at least $2 million a year off of a $7 million peak in 2016. Okay, so let's get into some specifics. So when we started looking at how we're going to decarbonize our heating source, we came up with 2 potential solutions to that for a building. The first one is to essentially insulate the hell out of it. And if you do that, you go so far that you no longer really have to heat it, and your natural gas problem is solved. So that's what we're going to talk about now. And then the next project I'm going to talk about is the decarbonization of the central plant, which is more of a distributed campus level thing. So there was a program in Ontario in about 2018 where they were basically handing out the greenhouse gas money they'd been collecting from the tax. And it was set up as a competition. So you had to come in with a very innovative project and say what you were going to do. So we figured, well, we better go all in if we're going to get the money. So we said, give us some money and we will retrofit this building to Passive House standards. So Passive House is widely regarded as the most energy efficient standard in the world. It came out of Germany. And this building, we knew we had a problem anyway. So it was built in the late 80s. It was originally the main library and front entrance to the college. We had since built a new building for those functions, and inside was now renovated to faculty offices. It's roughly 50,000 square feet of space. So it's not a small building, but not enormous either. And what we found once it was no longer a library and people were in these spaces more often is we had an awful lot of thermal issues. So from this picture, you can see a few things. Awful lot of glass block. And that's where we were having most of the thermal comfort issues, because there's almost no insulation there. It's too hot in the summer when the sun's coming on it. And then they were leaking. Half of them were full of water. It was just bad. So we're having all kinds of problems with this building. We had to do something with this envelope anyway. So what we did is we took off the entire skin of the building and replaced it. So on the left, it shows, this is a cross section through a window. This would be the window here. You can see my mouse, right? Yeah. Okay. So this is a window, and then this is the wall. So the wall was an inch thick of styrofoam with sandwiched in like an aluminum panel. That's all it was, with some seals. Almost no insulation. So that's what it was before. This is the new system now. So triple pane window, fine. These are Passive House certified. And you can see a few things. One, the window frame is buried in the wall now, right? That's to stop thermal heat traveling through the frame. This is a big block of pink insulation, like a solid styrofoamy stuff. And then above that, this is a mineral wool. There's 7 inches on the outside. This is the wall with the blue skin. And then on the inside, within the stud wall cavity, we spray foamed 4 inches of spray foam. So the new wall is 14 inches thick. So we've got 4 inches of spray foam on the outside, 7 inches of mineral wool on the inside, sealed tight. We did a blower door test to make sure it was tight. And so it's now really well insulated, the whole building. And there's a lot of details that go into the thermal as well. So this is the building during construction. And so what we did is we went in late April, we built a drywall wall 3 feet off the outside wall all the way around, because they were going to stay inside occupied in the faculty offices while we were doing this. And then from the outside, we demolished the outside wall and we started building the new wall. So we started with the studs, with the dens deck and the blue skin on the outside. You can still see some of the blue skin from these pictures. And then on inside, we spray foamed the cavity. We put the new drywall up so that by the time we got to September, we could open back up the inside, keep working on the outside at that point. A few other points here to talk about. At the slab edge, the reason there's this blue line here, that's where the floor slabs are. There's a special block of insulation that goes through there. That's even more insulating than the mineral wool that goes around it. We cut around the foundation everywhere we could. We dug down, we insulated the foundation edge, put it all back. There was originally a skylight on the top of the top floor. Got rid of that, roofed over, and then we pulled. It happened to be an inverted roof, so we pulled back the stone. We added more insulation. We put the stone back on top. We took the wall construction all the way up and over the parapet, because we've found in the past the parapets are a big heat loss. There used to be a vestibule on the outside, all glass. Gone now, it's inside. We took a little piece out of the foyer. What else can I talk about? Some of this stuff. Passive House certified windows, Passive House certified curtain wall. That's a lot of it, I think. Maybe I'll show it. So this is it when it's done. Another thing that sort of shows how far you have to go is this canopy here, which is mostly an architectural feature, but it's not attached to the building. So we put separate foundations for it. And if you went and you looked up between the canopy and the building, there's a 2-inch gap. It's so that there can be no possibility of thermal bridging through that thing. So yeah, it looks quite nice in the end to be done. But let's talk about the mechanical system. So after you go that far, we found that the mechanical system was way too big, way too big for what we needed. So we changed that also while the building was occupied to this new system. So we decoupled it from the central plant, and we went with an air source heat pump with a VRF system and a DOS unit for the ventilation. And it worked out quite well. We kept a lot of the duct work from the fan coils down, and it's big duct work in place. and we replaced the ductwork from the unit to the fan coil. So the new incoming duct to the fan coil is like 6 inches, and it's the old stuff leaving is like 18 inches. It's really stark to see that. I should have a picture for you. So we changed the mechanical system is what I'm saying. We also had a student involvement in this, and we've done this in several projects where we work with the Faculty of Applied Technology to form multidisciplinary teams. So in this case, there's the sustainable building technology people, there's HVAC, there's project management, there's supply chain, there's, I think, architectural design in there. And we give them basically the same problem as we gave the professional engineers. And they have milestones during the semester when the actual engineers talk to the students, and they say you're on the right track here or you're not, and they get a lot out of it. We got very positive feedback from this sort of project, and it gets that academic involvement in the project, which is crucial too. And here's some results. So pre-retrofit, and I have to admit, we didn't have the metering in place yet. This is a complete guess. It could be 400. I don't know what it was exactly. The model said we were going to be at 64. The last year, we're operating at 48. So these numbers are absolutely phenomenal. Like, this is way more efficient than anything new we're building. And it all comes down to that insulation level of the building. Another antidote I can tell you that came up during construction. So when we were building that mechanical system, there came a point where we had to disconnect the old one and go to the new one. And the contractor came to me and said, can we do that tomorrow? It should only be a day. Now, it happened to be February, and it was really cold in Toronto that week. We don't get much like this, but it was -20 all week. And I'm like, well, we're pretty well insulated. We'll probably get away with that for a day. And so they went off to do it. Well, it turns out they left it off for a week. We were without heat in a building like this in Toronto for a week, and nobody noticed. At the end of the week, the temperature was down to 21 C instead of 23 that it should have been. But okay. And that bears out in what we've seen. We're putting almost no heat into this building at this point, just a little bit. So what I'm saying here is this is really expensive. This made sense because we got free money, and also because the envelope was shot in the first place and we had to do something. But if you are in that situation, it's a good solution. And even if you're not, we should all be building to this standard for new construction. Like, it makes complete sense. I haven't quite convinced Humber to go quite that far on new construction, but we're almost there. The passive house certification process is pretty onerous, but the principles are the same. It doesn't cost much more money to install a little bit more insulation. Okay, so that's one way to decarbonize a building. Now I want to talk about our district energy system. So this was in the original master plan. And we deliberately decided to do it later. So the master plan is a 20-year plan. We thought, well, let's do the envelope stuff. Let's do the control stuff. Let's figure out what we have first. And then maybe when we get to the district system, the systems can be smaller. We don't have to buy as big boilers and everything else because everything's already been reduced. So we did it in that order deliberately. And the point of the project is to modernize the heating system on the campus and to move towards electric. So one of the things that changed from 2015 to 2020 was the emphasis on carbon became much more. The original plan actually had a cogen in this project. And we were like, well, yeah, it works financially, but we're generating all this additional carbon now that's kind of seems to go the wrong way. So we had to find another solution to that. So we're under construction already, and we'll be finished hopefully next November in time for the heating season. So what we have currently is we have a steam system on our North Campus, and it dates to the early 70s. And when we were starting looking at decarbonization, it quickly became obvious that it had to go. The steam system had to go because the temperatures are too hot and they're not compatible with heat recovery. So it was also very inefficient. We didn't have the whole campus connected to it. We also have a chilled water plant that we're pretty much not touching as part of this project because it was actually in pretty good shape. So first thing we have to do is we have to run a lot of pipes. This is an infrastructure project. So we have to, during the summer months, remove the steam pipes in most cases because they're in the way and put in the new hot water pipes. So the lines in red are what we're putting in now this summer. Next year, we're doing the lines in yellow. Some things here, we had 5 buildings that were not connected to the central plant previously. They were islanded, they had their own systems, including our student residences, which are over here. So we're connecting everything. All the heat and cooling will come from the central plant when we're done. So that's going to be great from a maintenance perspective and also from a heat recovery perspective. Another thing we did here was we were worried about redundancy. So we've built a loop, if you can see around there. It's not like a round loop, there is a loop. And that is all sized to, and they're 10-inch pipes that run through the buildings at that point. And it's there for redundancy. So if we ever get a break, we can feed from the other direction. But also we have additional capacity. So if somebody decides that we're going to put a new building over here, we can tie into that loop and feed it with the decarbonized system. And we're no longer getting islanded buildings with who knows what heating them. So all in all, it adds up to about 4.5 kilometers of pipe that's going to be going in as part of this project. And so here is what's happening in the central plant. And this, I guess, is the fun stuff. And it gets at the question some people were asking is, how do you do this in the campus? So first of all, we do have gas boilers. We're putting in gas boilers, gas hot water boilers with enough capacity to take the entire load of the campus. Actually, N+1. So we're doing that for a number of different reasons. One, we're still going to need some gas heat on the coldest days. 2, for redundancy. If the power goes out, we want to be able to heat the building because we can't have an emergency generator big enough to do it electrically. And 3rd, we think the Ontario electrical peak is going to switch to the winter, in which case we'll need this for load shedding. So there's gas boilers. They're already in. They've just arrived. They're getting hooked up. Secondly, we're putting in an electric boiler. So we were really surprised when the consultants told us that in Ontario, it is cheaper to operate an electric boiler than gas off peak. So in the middle of the night or on the weekends, because we're on a spot market rate, it is cheaper to heat with electricity. We were just floored by that, absolutely floored. But they were right, it's true. So that's going to run off peak and take a lot of the load and a lot of the carbon out. And then the last piece is the heat pumps. So what we currently do, and I think what most people do, is we have to cool our buildings year round. So in the core of the buildings, when you've got all those students there, those classrooms are getting hot. And we currently do it using outside air, right? We just bring in a bit more fresh air in the winter and we flush it out and we send the extra heat out the roof and it's gone. So instead of doing that, we are going to use the cooling system. So currently we run cooling in the summer, turn it off, run heating in the winter, turn it off. So we never have both at the same time. Now we're going to run both systems at the same time. So we're going to use the cooling coil that's already there. We're going to bring that heat from the people back to the central plant, and it's going to arrive back at the central plant at 25, 30 degrees C or something like that. So instead of pushing that through the cooling tower like we do now and throwing that heat away, We're going to put it through a heat pump, single stage heat pump, and that's going to move that temperature from 25 degrees to 70 degrees, and we're going to put that back in the heating loop. So what we've essentially done is we've recovered the heat from the people at the central plant. And the engineers tell us that this is probably going to be 40% of our load, our heating load. That's a lot. So yes, we have to use a bit of electricity to pump stuff around and do the heat pumps. But for 40% of our free heat, that's pretty impressive. So these, we're not exactly sure how we're going to operate these, but obviously the heat pumps are going to work during the day when there's people. The electric boiler is going to work at night. When it's off peak, the gas boilers are going to fill in the gaps, is what we think. We've also designed this so that in the future, we can add a geothermal field and maybe reduce even further reliance on those gas boilers. But because we have a hot water loop operating at much lower temperatures, we can put in heat from anything. So one of the things we looked at in the feasibility study was sewer heat recovery. We couldn't quite get there logistically, but if that comes in the past, we can put that heat into the system. We could get heat from a biomass boiler if we want to do in the past. You know, it's very flexible. If the technology changes or whatever, we have the infrastructure to do what we need to do. And finally, the last piece is, I told you that the original plan was a cogen. Cogen was there because it mints money. But we didn't want to do that because of the carbon. So we ended up with a battery. We've bought a 4 megawatt-hour battery that will run probably through a 3-hour window and take a meg off our load. So in Ontario, they highly incentivize this. And this battery by itself will pay us somewhere between $400,000 and $500,000 a year. So very fast payback. But we didn't just pull out the payback of the battery. We wrapped it into the entire project to get a better payback on the entire project. I know that the battery doesn't actually have much to do with the district energy system. Nobody else knows that because I didn't tell them, but it's all part of the same strategy to reduce our electrical costs. So that should be arriving this fall, hopefully. We're going to try and get it operational for next summer. So in terms of results, just the switch project, the district energy project, it's going to reduce our carbon emissions for the whole college, not just this campus, by 33%, which is enough to meet our original goal of a 30% reduction. It reduces natural gas use on the campus by 70%. And it also goes a long way to the efficiency because the steam system's gone. It was very inefficient. And we pick up a lot of efficiency from that and from the heat recovery. So we pick up about 15% of that 50% that we're trying to get to. So this will go a long way to getting us to that goal. We modernize the entire heating system. We get rid of all that deferred maintenance, all those other pieces, gives us redundancy, gives us flexibility for the future. So we're very excited about that. It does make centralized operations. It's also more complicated, frankly. I'm not exactly sure how that's going to go. We'll find out soon, I guess. And in terms of the financials, this is what we showed to our board. So we used a 30-year analysis and the net present value of the project. It's not on here, but it's a $31 million project. We'll be up $11 million, $55 million in savings over that 30 years. That savings comes from a number of different places. There's the demand charge savings from the battery. There's the efficiency savings. There's the avoiding the carbon tax, excuse me. Try that. Okay. It's a big one. The carbon tax is a big one. So a straight payback of 18 years. And we start at 1.5 million and it goes up fairly rapidly from there. And we get rid of $5 million worth of deferred maintenance almost immediately. So all in all, we have a decarbonization infrastructure project that is giving us a payback, and everybody's pretty happy about that. So I'm going to stop talking there, especially since my voice is gone, and go to questions.
Thanks, Spencer. It's such a fascinating set of projects and such a comprehensive approach. I mean, I think it's so informative that it took the, you needed to have that more integrated management plan and goals in place, and then it makes it relatively easy. I'm sure that upfront process, was more complicated, engaging so many folks, but then it meant everybody agreed to those targets, and those targets, are very aggressive. They're very ambitious. So I'm, interested in learning more. I understand you're benchmarking against institutions in Europe, but, and then it sounds like, my understanding, maybe this is a question, is it looks like your 2034 goals, you may be achieving much sooner than that. Is that right?
Yeah, I think we're going to hit them. I think once this switch project is done, which will be next year, we'll be up to around a 45% reduction in energy use. So we won't be quite to 50, but we're pretty close. And the rest of it's going to come from operational things. So yeah, it's gone really well.
Fantastic. And so, yeah, I mean, I'll be very interested in, once the project is fully implemented, it'll be in place next year. You probably won't have data right away, but start to understand how that looked, how things were implemented, because I think there's lots for us to learn from this. So yeah, I had that, but I want to go to other folks' questions. If you have questions, just you can either pop them into the chat or put up your hand. Aaron, please go ahead.
Yeah, I was wondering why your energy use, why you're tracking per square foot instead of absolute.
Because of the growth on the campus.
Oh, okay, so you're intending quite a bit over.
Yeah,
over the
exactly.
project.
Yeah, that's why.
Yeah, that makes sense for sure. At one point you spoke to the potential for geothermal field. I know that's also one of the, it sounds like talking to one of the energy managers at University of Calgary, that's also potentially a part of their approach. Have you actually started to look into that? Do you have an idea where that would be and what the energy source looks like and whatnot?
Yeah. So we looked at it during the feasibility study on deciding what the central plant would look like. And so we got a study done by the people, they look at the geology and that sort of thing. We didn't do it because it was too expensive. It was pretty expensive. But there's a new project coming up at Humber where it's a new building. It's an athletics building and it's going to get a sports field. I think I've got everybody convinced to put the geothermal under the sports field. So part of a capital project. Now we have all the central plant ready for it. So I think it makes sense. It's like straight carbon savings at this point because all the infrastructure is already done.
And yeah, that's interesting because that's exactly the approach that UC is at least considering at this point. So I think that it's great when you can use those fields and they can become, useful for other things as well.
Yeah.
Any other questions that anybody had? I was curious about the effect of the passive. It sounded like it was, you could tell from the project, it must have been very expensive to retrofit, but at the end, you also kind of indicated that doing this from the start and putting in that kind of thick walls is relatively inexpensive and maybe cost effective. Is that right?
Yeah, exactly. Yeah. So yeah, it's very expensive to retrofit into a building. It works. We've done it, but it's like, I'm not good. I haven't done another one. Let's put it that way. But in a new build, to take those passive principles and build them right into the specs in the first place, it's relatively easy. we found that if you put 5 inches of insulation or 7 inches of insulation on the outside of the building, it's not much more money, right? You've got a bit of a longer thick clip and the bit more, like there's no more labor, you're there anyway. The window spec. So, but the way we're driving it in our new building spec is we're pushing down the Teddy number. So we're doing it on a performance based rather than saying thou shalt do passive house. Because one of the problems we had is getting the windows. You can get them in Canada, but we couldn't get them quick enough. So they came from Germany and, you know, they were 3 times the cost.
Yes, and that makes so much sense. It is, I mean, our campus's existing buildings are a huge challenge. Understanding that, you know, the working on the envelope, I think we all understand that is great and valuable. There are still always new buildings going up. I mean, we have new buildings at Lakeland College, at SAIT, the replacement, at McEwen. And if they can make sure, and I agree, like meeting the passive standard, or actually any standard, is a little bit secondary. It's nice, but if you can get the performance, maybe not meet the standard, but get the performance you want to meet your emissions, that's more important. And understanding where that performance can come from is so important. And we're constantly having discussions about an issue that you spoke to around metering. So putting in metering it's not cheap, and knowing what level we need to go to is so important. Having it at the building level and then the software layered on top often seems to be able to get you quite a bit of information about the load characteristics that can help as well. What did you want to talk more about metering and how that?
Yeah, but I just want to finish off on the passive house. The other benefit that I really like is from a life cycle perspective. So one of the problems that we have is, let's just say we replaced and we put heat pumps in the central plant. 20 years from now, they're coming out because they're end of life. We're putting new ones in. Whereas the insulation stuff, it's there for 50, maybe more. And nobody's going to screw it up. Nobody's going to operate it wrong and not get the savings out of it. Like it's done. So I like those for those reasons. Metering is way more complicated than it sounds. And because it's not just the meter. It took us 4 years to get the data right. So from the time the meter went in, because what we found is it wasn't set up right. It's not measuring in the right units. It doesn't have the right factor. Oh, it's offline now because of IT, whatever the reason is. Thermal was even more difficult because you got to have the right meter in the right place with the right pipe, and they're very complicated. And then all the data's got to go somewhere, and then you got to do something with it. So we used a Niagara server. It's all sitting in one place. And now we're pulling data into SkySpark and the BAS to do stuff with. But it's very complicated. But very essential. You got to do it.
Yeah, exactly. And there's no question. I think particularly UFC, Annie Claude, this is this is exactly where you live. And it's so complicated, and each of those meters has different issues around it. And they're difficult. There's such a cross between IT, I think, and other types of engineering. So those issues are difficult. And so we really appreciate folks like you and Annie Claude working through those, and maybe potentially having, there's going to be ongoing opportunities to share what the issues are and be able to, anticipate them, so that others of us don't have to figure that all out. So that I wonder if there might be opportunities to kind of meet to discuss that, but I'm certainly interested in learning more about your experience with the metering.
We had no idea what we were getting into at the beginning.
Yeah. So have you actually kind of built that expertise then in-house to
now we do.
Yeah. Okay.
Yeah.
Nice.
Yeah.
Excellent. Wow, so much really interesting information that's so relevant. I really appreciate the work you've done. Are there any other? Oh, there are lots of other questions. Sorry, I didn't notice that. Jason.
Yeah, great presentation, Spencer. That's some really good stuff. I guess I go back to earlier in your maybe where you let off. Any guidance or suggestions on the whole governance piece? Like here at Norquest, like we're a smaller campus. We don't have a sustainability office or team right now. I think we're trying to get traction with that, but the whole piece around strategy and making it more of, I guess, a college level thing versus just something that's trying to be driven within facilities, because we're trying to do things ourselves and sometimes we get traction, sometimes we don't.
Yeah, we had the same problem at the beginning. You have to have a buy-in from somebody at the top. Somebody has to get this, and it could just be money. It could be they're looking for the operational savings. They could be interested in the carbon savings. Whatever the hook is, somebody there has to be interested or it won't work. And then you can sort of set the structure up. You don't have to have the sustainability team, honestly. Like it could be just a straight facilities piece, but you still need to have people involved from purchasing and finance and the academic side to drive those discussions. And the most powerful part was everybody understanding what we're doing and why we're doing it. What happens if we don't do it? Where are our utilities going to be 10 years from now? With inflation and carbon tax and all the other things, right? Because when they saw that graph, like now they're interested, because it becomes a risk mitigation piece. And so, and after we went through that process, so I don't tell anybody now what the payback is on an individual project. I know what it is, but I don't tell them, because I don't want somebody cherry picking. I just say it's an IMP project. They say, okay, because they're getting the savings that they want.
All right, thanks.
Yeah, that's a great question around the governance, getting the buy-in that you need to be able to move projects forward. So it's not just the individual project, but it's the idea of what you want to go ahead with. And I have some experience talking particularly to banks where they're very interested in risk management. We're all seeing that issue come up more and more and being able to talk that language. So yeah, if we can have, if people have questions about that, I'd like to discuss. I have some ideas. Annie Claude.
Yeah, thanks. And thank you for the excellent presentation and good work. It's very inspiring. So I have a more, I guess, technical question regarding the building. So you went from a steam system to what is, maybe a third generation, like a district energy system. How did you do the conversion of the buildings? So were they already running at the right temperatures, or do you have to do pretty deep retrofits in those as well?
We were lucky in that we had steam coming from the central plant, but it got to the building, there was a heat exchanger where it was converting it to hot water and circulating it through the radiators and whatever. So we just took out the heat exchanger and went straight in with the hot water. And what we did during design is we played with the temperatures. So we lowered the temperature of that hot water loop until we got complaints. And then we knew that was the minimum, like we couldn't go any lower than that. And that's how we knew what the lowest temperature of the loop could be. And the design came from there.
Oh, interesting. Thank you. And just another quick question. So when you do your design, is it for today's temperature, or are you looking at future temperatures?
We use today's temperatures, yes.
Okay.
Yeah,
great. Thank you.
Excellent. Thanks, everybody. If there are any other questions or if things come up, please just feel free to forward them, and I'm sure we'll be happy to answer any questions that come up. Or if you'd like to meet again to talk about some of these issues, we'd be available. We're going to be publishing, or we've made a recording. We'll publish this so that it's available for other folks to see as well. Spencer will be forwarding his slides, and we'll send those out so that you can take a look through those. I mean, they're really excellent slides, so much information in them. But I think if there's nothing else, no other questions or anything that someone would like to